Hey everyone, my name is Nathan Peck, and I'm a developer advocate for EC2 Container Service. In the last couple segments, we took an initial look at the core concepts of ECS and then covered how to get network traffic to your containers using an application load balancer, which is automatically managed by ECS. Once you have your containers running on ECS and HTTP requests flowing into your containers, the next step is scaling. Most services will see variable request volume throughout the day and week. Fortunately, ECS has auto-scaling features built in that are designed to help your ECS managed services react to variable conditions. In this panel, you can see that ECS has been capturing statistics such as CPU utilization and memory load for my service. These stats are all being piped into CloudWatch. And here, you can see that I've created alarms based on these stats, and these alarms are tied to scaling actions. So when CPU utilization for the service is greater than 70%, ECS will automatically launch another task. But if the CPU usage dips below 20%, then it will start removing tasks from the service to free up capacity on the cluster to be used for other purposes. Let's see what this auto-scaling looks like when the service is under load. In this dashboard I created, you can see an overview of all the stats for all of the services in the cluster in one place. You can see from this request count graph at the top that I'm currently running a load test that ramps up every 30 minutes to approximately 60,000 requests per minute. But this total request volume is being distributed across a number of different services. So this pink service is doing roughly 6,000 requests per minute, whereas the purple service is doing 13,000 requests per minute. And some of these services are doing more CPU intensive jobs. For example, the auth service has to do 10-round bcrypt hashing of password plaintext in order to validate login attempts. That's a very CPU intensive task. Each service is going to have a different level of CPU demand that grows at a different rate as the load test progresses. So each service also has its own auto-scaling policies that are operating independently, and that's what you can see from this graph of CPU utilization per service. The graph looks somewhat sawtooth. Each time the CPU for a particular service crosses the threshold, it drops back down again as ECS launches more containers to distribute the load across. If the request volume drops back down, it will cause the CPU usage metric to drop as well, and ECS will respond by scaling back the number of containers. This auto-scaling integrates seamlessly with the application load balancer to avoid dropped requests. When ECS is scaling your service down, it transitions one or more containers into a draining state so that the load balancer stops sending new requests to that container. Once the container has finished handling all in-flight connections, ECS stops the container. In summary, ECS has auto-scaling abilities that give you another level of auto-scaling beyond just the number of instances you run. ECS auto-scaling is ideal for use with reserved instances. To get the most value out of your reserved instances, you want to run them at all times, but you also want to get the best utilization out of them. By scaling services up and down, ECS can ensure that your reserved instances are being well utilized throughout the day by different workloads, perhaps web traffic during the day and background batch processing at night. And best of all, ECS automates everything so that it's hands-off. No developer intervention required. Thanks for watching.